All right, geometry, lesson 22, finding the areas of quadrilaterals. We talked about quadrilaterals a little while back. We talked about kites, rhombuses, parallelograms, rectangles, squares, all those types of different things. This won't work for, I think we won't talk about finding an area of a kite necessarily today, although you could break a kite into triangles and find it that way. It wouldn't be impossible to do. But we want to recall from lesson 13 that the area of a triangle can be determined by using the formula base times height divided by 2. So hopefully you guys understand as I write some of this stuff up. It's not necessarily written the way I would like to have been able to type it in there, but there it is. Where B represents the base of the triangle, H represents the height or altitude, and A is in square inches, or units. Sorry, not inches always. If a diagonal is drawn in a parallelogram, we end up with two identical triangles. Okay, these two triangles here are shaped exactly the same size. So if I can find the area of one triangle, then essentially all I'm really doing is doubling the area of that triangle, correct? Okay. Let's see. So the area of a parallelogram is twice the area of one of the triangles. So we end up with an expression of finding the area of a parallelogram is base times height divided by 2 times 2. What ends up happening with the 2's in that equation? They cancel out. So finding the area of a parallelogram simply becomes base times height. Okay. Another way to look at this, and if I could, let's see if we can look at this. If I were to cut that piece off, right, from that vertex down to that point and move this section over to here, it would end up filling this in perfectly. And if you look at this shape, that shape becomes a rectangle, and that's why base times height also works in that sense. Does that make sense? Okay. And you've probably seen that explanation before. Okay, so to find the area of a parallelogram, take base times the height or the altitude. Okay, and that's what you see down here. To find the area of a parallelogram, use this formula where B is the length of the base and H is the height. Okay, any questions about that? Okay. Since rectangles, rhombuses, and squares are all types of parallelograms, the areas of those shapes can also be found using that same formula. So rhombuses, squares, and rectangles are all parallelograms, so we'd use base times height on all three of those. Now, we'll find out here in a little bit that sometimes we don't always have that given information for a rhombus, and we'll use a different formula for a rhombus in certain situations. A trapezoid, however, is not a parallelogram. We cannot use base times height to find its area. It is a quadrilateral. It's got exactly one pair of parallel sides. The height of a trapezoid is the segment that's perpendicular to both those parallel sides. And so we refer to those parallel sides as base 1 and base 2. Okay. All right, two congruent trapezoids can be connected to form a parallelogram with side lengths equal to base 1 plus base 2. Basically what they're saying down here is if this is base 1 and this is base 2, right, then this is base 1. So if I add base 1 plus base 2, that's what I'm getting. Now I have a parallelogram, right? So what I would end up with is I can do base times height with this. But because my area is going to be twice what it should, right, I'm going to have to divide by 2, which is how we wind up with a formula of base 1 plus base 2, okay, which is the base of that parallelogram, times the height of it, okay, times this, divided by 2. Okay, so that's how we get the formula for the area of a trapezoid. Okay, and so you see that following on down here. So they're going to put it in those same terms. I don't really feel like going back and reading it. Again, it's really hard to write all of that in a way that can be shown well there. So this is how you want to see that formula written. Base 1 plus base 2 times height, all in the numerator, divided by 2. Okay, that's our area formula for a trapezoid. Okay, do we understand that? Okay. Okay. Then we get into a rhombus. We want to recall that a rhombus is, again, it's a type of parallelogram with four congruent sides. We could use base times height if we had that information. But like I said, sometimes they won't always give that to you. A second method uses the diagonals of the rhombus, which are labeled diagonal 1 and diagonal 2. It's fairly simple. In this case, it's our area formula is diagonal 1 times diagonal 2 divided by 2. Okay? But the area formula for a rhombus, especially this formula, is on our list, probably one that's going to get forgotten. In fact, I'll tell you now, even though I don't know if it'll make much of a difference. I've said this for years because the question comes up on the test. You'll see a question show up on a test. We might even see it today in our work, where they give me like a complex possibility for our diagonals, where they might say, you know, diagonal 1 is x plus 2, and diagonal 2 is x minus 3, right? So I would have to multiply those, right? And in multiplying those, I would need to FOIL them, correct? So I'd wind up with something like, you know, x squared minus x minus 6, right? And people tend to stop there, but my formula says I have to do what with this? Nope. Nope. Divide by 2. See, we've already forgotten it. Okay? And our formula is literally, well, I guess I erased it. Or no, it's, where was it? Right, I don't know. Diagonal 1, I'll put it over here. Diagonal 1 times diagonal 2 divided by 2. Okay? All right, hopefully we've got all that down. It's there at the bottom as well. All right, so let's look at some questions we can answer. Okay, we want to find the area of a trapezoid with parallel sides that measure 5 feet and 10 feet. It's got a height of 3. Jordan, you seem pretty tired here, so I'm going to call on you. Okay, help me out here. Let's solve the area of a trapezoid, question number 1. If you still have your notes pulled up, you can, all we're doing is taking these numbers, plugging in into our formula. Okay, so that's our formula. Let's take the information that exists up here and substitute in. Okay. What do you want to put in for B1? 5. What do you want to put in for B2? 10. What are we using for our height? 3. Dividing by what? 2. What's the first thing I want to do there? Parentheses. 5 plus 10? 15. So I got 15 times 3 divided by 2. It's 15 times 3. Okay, so we're at 45 divided by 2. Should be something like 22.5 feet. And because it's area, what should it be? Squared. Very good. Thank you. 22.5 feet squared. Okay. The area of a parallelogram. Katie, help me out here. What formula do you want to use? Area of a parallelogram. No, because this, what he was solving was a trapezoid. This is a parallelogram. Nope, it's not a rhombus. I don't have diagonals here. Okay, you've got your notes. Go back and look. It should be like the either first or second slide. In this case, no, it's not divided by 2. That's the area of a triangle. So, nope. Parallelogram. Yeah, it's got 2 times the base times height divided by 2, but what did I tell you is going to end up happening with those 2's? And so you come down here, and that's where in your box you're seeing it, right? There's your area formula of a parallelogram. Its area equals what? Base times height, right? So let's substitute in. What do we want to use for our base here? 13. And what's our height? 5.5. Can you go ahead and solve that for me? (71.5) centimeters squared. All right, Chandler, you're up. Okay, number 3, find the area of a trapezoid. Tell me what the formula is first. Okay. Okay, what do I sub in for B1? What do I sub in for B2? What do I sub in for height? Okay, 6 plus 12, 18 times 20, 360 divided by 2, 180 inches squared. Okay, so far so good? Let's see. Here you actually have to find these distances, but they've all been graphed the same. So my height is 3, my base 1 is 2, my base 2 is 1, 2, 3, 4, 5. That should be enough information, right? 2 plus 5 times 3 divided by 2. 7 times 3 is what, 21? 21 divided by 2, 10.5. 10.5 units squared. The very first thing that you want to check, though, is make sure that the coordinates of that trapezoid match the coordinates that they've given you, because there might be a difference in here, and you want to double check that, okay? Okay, so you're given a lot of trapezoids to work with. Okay, let's look at number 6. A rectangular plot of land has a length of 3.5 miles, a width of 8.5 miles. What's the area in square miles? What do I do with those two numbers? Base times height. Because it's a rectangle, rectangle's a parallelogram, base times height, 3.5 times 8.5 should come out to, what, 29.75 miles squared. Okay. Do we feel like we've got a handle on the trapezoids? Good, because I think they've come up quite a bit. Do we have a handle on our parallelograms? Okay, good. Let's look at question like number 9, where it's not just straight numbers. Right, we've got a parallelogram here. It's got a height of 8y, a base of 3x. What do we want to do with those two things? 8y times 3x. What is that? 24xy units squared. Okay? Because we're talking about area, we have to have units. If they don't give me something, we're going to go ahead and write it in. Okay? 24xy units squared. Okay? Where are we at here? Let's get that guy out of the way. That's it for that. Like I said, be aware of a question that will involve, and I wish they had, here, let's just make one up just so you're familiar with it. Okay, if they do give you a rhombus, okay, and to know it's a rhombus, we're going to have to see it like that, okay? Or, yeah, that'll work. Let's see. Let's say that that's 6. This is 8, just so we're familiar. What am I doing there? What do I do to solve the area of that rhombus? 6 times 8 divided by 2. Okay, what is it? 24 units squared. Okay, should be pretty easy. Like I said, it gets a little harder if they start applying algebraic terms to it, where I have to FOIL and then divide that by 2. There is a question that'll show up like that on the test, so I'm just trying to make you aware of it. Okay, we'll stop there. You guys can get started on your homework. You guys have about 15 minutes.